Let us solve a problem on resultant of coplanar and concurrent system of forces. So question is a system of forces acting on a body which is resting on an inclined plane is shown in figure. This is the given figure. Find the resultant force if theta is equal to 60 and if W is equal to 1000 Newton and N equal to 500 Newton, F is equal to 100 Newton and T is equal to 1200 Newton. Now here in this case for the body no dimensions are given, so we can assume this body as a point object and then we can find out the resultant force. So here in this case let me draw this inclined plane. This is the horizontal and this is the inclined plane. This one is the inclined plane. And this angle is theta. Now I assume this as a point object. Let us say the body is nothing but a point object like this here. So W is acting vertically downward, so I can draw this one. And N, see I am applying here the law of transferability. Either you can show from here to here W, or same, both are same. N is acting here, or I can show like this also, applying the law of transmissibility. Instead of pushing, it's like a pulling force. Both are same. Applying the law of transmissibility such that now this angle is 90 here. So this implies that this angle also 90. So this is the inclined plane and this direction nothing but it is the normal to the inclined plane. And here we have another force T along the inclined plane and another force F down the inclined plane F. So these are the forces acting on this body which is resting on the inclined plane. Question is to find out the resultant of the system of forces. So for that we need to see what are the forces acting along the inclined forces. So we will try to solve this problem in two cases and two methods. Let us see the first method. So as usual method, like if you take x and y axis, so this is our x axis and this is the y axis. So this positive x axis, positive y axis. Now we have to resolve all these forces along the x-axis and y-axis, two components. So for that we should know the angles made by these forces either with the x-axis or with the y-axis. This angle is theta, this angle is theta, so that implies this angle also theta. So now we know the angle made by t with x-axis, fine. Now here this angle is theta, so this angle also theta, this angle is theta, and total angle is this angle is theta, this also theta, and it will become 90 minus theta because this total angle is 90 and this total is 90, it will become theta. From geometry, I repeat, this angle is theta, so this angle also theta, this total angle is 90, this is theta, it will become 90 minus theta, this angle, and this angle is 90, so it will become, this angle is 90 minus theta, it will become theta. So we know the angle made by this one with n with the y-axis, and this angle here is theta. Anyway, and W is already acting along y direction, so no need to resolve W. So now let us resolve these forces along x and y axis. So let me draw our usual method. This is our point object where this one, say this is some A, so same A. Let us resolve this T into two components. One is along x axis, other one is along y axis. So it will become now two components are, one is this and other is this, and this is making angle theta. With this one it will become t cos theta, and this is t sin theta, and coming to this n, it is second quadrant, so two components are, one is this, other is this, and direction of n is away from this point A, so both the component direction also must act away. Then and n is making an angle theta with this component, that implies with this component it will become cos, so this is now n cos theta and n sin theta. So now coming to this force F, and it is in the third quadrant, so two components are, one is this, other is this, and this F is acting away from this point A direction, so both the component direction also away, and this F is making an angle theta with this component, it will become cos, so this is F cos theta and this is F sin theta. And coming to W, so W is already acting along y direction, so no need to resolve it. Only now see this T is inclined force with respect to x or y axis. Similarly N also inclined and F also inclined, but this W is already acting in y direction, so no need to resolve it. So simply I will show W. So we have resolved all the forces along x and y axis. Now let us find out the resultant force using their components. So here this Rx equal to sigma fx, that is equal to, so this is minus f cos theta because acting along negative x direction, minus f cos theta and minus n sin theta and plus t cos theta, and these values are given, f and t theta values are given. Substituting what we get,